All right. Today we are differentiating regular logarithms, not natural logarithms. Okay? And we are differentiating exponential functions where the base is not just e. Okay? The base can be any other number. All right? Yep, this is still all sorts of types of differentiation.
Wait, so this could be on the test?
So yeah.
This is going to be
This
on the
is.
test.
Oh.
So today
7, right? Tons.
Today our goal is to find the derivative of some number raised to the x power. And also find the derivative of a logarithm of some base a of x. That's our goal. That's what we're trying to figure out. Okay? So, you'll be able to kind of box those in at the top at the end of the day, but I'm going to go through how we come up with those right now. Alright? So I'll come back to this one.
I'm going to need a lot of space for
I would say what I'm about to do is kind of showing you how we get these derivatives. You are welcome to memorize this first one for sure and not have to know why. But I'll be completely honest with you. These two derivatives were always kind of difficult for me to memorize, but going through the proofs of them or why they work here the last couple days is helping me remember why a little bit easier versus just flat out, oh, you know, the derivative of this is equal to this. I just know it because I have all these things memorized. Okay, so it's entirely up to you how much of this you want to put in your notes. If you just kind of want to follow along, that's what I'm doing. I think that's fine too. Obviously, it's on the video if you need to come back to it. Okay? All right. First of all, any number is equal to itself. Okay?
Is it all lesson?
Okay?
We're done.
You can handle this, right? Okay. I am going to take the natural log of both sides of the equal sign. Fair enough? As long as a is a number greater than 0, that's always going to be true. Okay? So the natural log of a is equal to the natural log of a. Everybody's good with that? Okay. Now I'm going to change forms. What's the little base right here?
E.
E. And you take that little base and you raise it to what?
A power.
No, careful. You raise it to this
To
side,
the
right?
equals side.
So e to the ln a
Equals A.
equals a. Okay, I'm changing forms now. E to the ln of a would equal a. That's that changing from logarithmic form to exponential form. Okay? Remember we did this yesterday in class where I had the ln of a equals b. Really there's an e there, so you could say e to the b equals a. You guys remember that?
Yeah.
Okay? That's what I just did. Except it's a little bit more complicated. It's not just an a and a b, but I did the same thing. Okay? And now, if I raise both sides to the same power, that's okay too, right?
Yep.
So I just raise both sides to the x power. And the reason I'm doing this is because now you can actually see over here this a to the x, which I showed you at the top of your page. We're going to find the derivative of a to the x. Okay? Now, I'm going to go one more step. When you have a power raised to a power, like if I had x squared to the 5th, what do you do with those powers? Multiply them. So I'm actually going to write this out one more time. I'm going to write this e to the ln of a times x equals a to the x. I can multiply those exponents together. The ln of a times x. So e to the ln of a times x is equal to a to the x. So these are equivalent things, okay? These are equivalent items. They're the same thing.
Did you see that when you have like two of them, you multiply or do you add?
When you raise a power, so you have something raised to a power here, and then you raise that to another power, you multiply both powers
Oh,
together. So
okay.
that's why the ln of a and the x are being multiplied
Okay,
together right
Gotcha. Yep.
there. Okay? Also, we maybe simplified problems like this before in Algebra 2. E to the natural log of 3, you know what that equals? The e and the natural log cancel each other out in a sense, and it becomes 3. So that's really what's going on here. E to the ln of a is really just a. So you have a raised to the x power equals a raised to the x power.
So you're
Okay.
just writing it too.
Yeah, I'm writing it two different ways.
Alright.
Okay? The reason I'm writing it two different ways, because if this is equal to this, didn't I just get done teaching you yesterday how to do derivatives of e's and natural logs? So instead of doing the derivative of this, I'm going to do the derivative of this because we know how to do it. Okay? So, if I wanted to do the derivative with respect to x of a to the x, instead I could do the derivative with respect to x of e to the ln of a times x. Because this and this, they're the same thing. Right?
So is that what you had problems memorizing?
No, it was more of the that I had a little bit of an issue memorizing, just because I didn't know that well enough, and then also how we get the derivative.
Is that what you want us to put in the top ones? That
No. I'll come back to that. I will come back. We haven't done the derivative yet.
All right.
Okay, we haven't done the derivative yet. But we're going to right here. Okay. So, what is the derivative of e raised to some power? How do you do the derivative of e to the 7x? Well, what is the derivative of e to the 7x?
7x.
E to the 7x times 7, right? The derivative of e to the 7x would be e to the 7x times 7. So we're going to do it very similar here, except we don't have 7, we have ln a. Okay? So the derivative of e to the ln a times x would be e to the ln of a times x times ln a. Because the ln of a is a number, right?
Yeah.
We don't know what a is going to be some number, right?
Yes.
So times ln of a. Because remember, ln of a is like 7. It's like 7x. Okay?
Yep.
So the derivative of e to the 7x would be e to the 7x times 7. But it's not 7, it's ln a, whatever that is. Depends on what a is. Okay? Now, isn't this right here equal to this? Right? They're the same thing, aren't they?
Yep.
So really, wouldn't I have then this times the ln of a? Because this is really this. Here's my derivative of my exponential equation. So the derivative of a to the x is simply a to the x times the ln of a. It's not a terrible one to memorize. But I just think going through the proof of it probably helps me a little bit. So if you want to do the derivative of 5 to the x power, the derivative of 5 to the x power would be 5 to the x times the ln of 5. Questions? Okay. Everybody got that one done? All right. Okay. So, how we did that one, whoops. How we found the derivative of this one was we actually kind of changed this, a to the x, to something in terms of e's and ln's, right?
Yep.
Okay. We're going to do the same thing with the logarithms, because we know how to find the derivatives of e and the ln, so we're going to change logarithms to e's and ln's, or actually just ln's for that matter. Okay? So, alright. Let me do it this way. Let's say I have y equals log to the base a of x. Okay. I know this is what we're finding the derivative of here in a second, but I'm just going to write it as an equation like you saw in algebra 2. Alright. Change forms. Change it to exponential. Something to the something equals something. A to the y equals x. Very good. A to the y power equals x. Let's natural log both sides. So ln of a to the y equals ln of x. Let's move the y out to the front, because we have logarithms, so we can do that. Y times the ln of a equals the ln of x. And then if I get y by itself, I divide by ln of a. Okay? So y would equal the ln of x divided by the ln of a. Everybody's good with that? And I'm going to change how it looks here just a little bit to be 1 over ln of a times ln of x. Is that the same thing? I know it's working backwards a little bit. It's kind of like unsimplifying the fraction. Okay? Yeah?
Can we just send those kids next period here? Or,
Yeah, they can come here during 7th. That'd be great. We got tests going on stats anyway, so they can.
okay.
I just won't give them the stats test.
That'd be fine for them too.
Yeah. All right.
So did you just separate? Or
Yeah. Yeah. You know, like if I had 1/5 times 3, that'd be the same as 3/5.
Okay. Yeah.
Right?
Yep.
Okay. So then would you agree then that this, what we're trying to find the derivative of anyway, is equivalent to this? They're both equal to y, right? I haven't done anything illegal here. So log to the base a of x could also be written as 1 over ln of a times ln of x. So this is actually equivalent to this, and now we can find the derivative of that and we'll get our answer. So I'm going to do, my goal is to do the derivative of log to the base a of x. So if I want to find the derivative of log to the base a of x, I really can just find the derivative of 1 over ln a times the natural log of x. Because that's what this was equal to. So to find the derivative of this, I instead could just find the derivative of this because they're equivalent expressions. And again, why do I want to do that? Well, because I know how to do derivatives of natural logs. I don't know how to do derivatives of regular or other just logarithms.
Is there a way to do those without getting into the terms of natural? Or is it just
No,
common?
this is the proof
You
behind
have
it.
to go
Mhm.
with natural log.
Yep.
Okay.
So this derivative actually is very easy.
Perfect.
Okay. 1 over ln of a is just a fraction, like 1/3, 1/5, 1/7, 1/8. Because a is some number and 1 over the ln of a is 1 over that number. So this is really just a fraction. So really all you have is essentially I'll use 3 for example, 1/3 times the ln of x. How would you do the derivative of 1/3 times the ln of x? One-third times 1 over x. Yeah. Because what's the derivative of ln of x?
1 over that
1
x
over
value.
x, you know. So if I had y equals 3 times, I'll even just use a whole number. If I said find the derivative of 3 ln x, well you take 3 times what? 1 over x. Because the derivative of ln of x is 1 over x. And the 3 just stays out in the front like a coefficient always does when you do derivatives. This is just a coefficient right here. That's all that is. Okay? So your derivative will be 1 over ln of a times 1 over x. Which simplifies pretty nicely to 1 over, I'm going to put the x in the front, x ln a. So now I can go back. The derivative of a logarithm to the base a of x is equal to 1 over x ln a. X times the natural log of a. So those are your two derivatives that you'll be using today. Alright.
So they're just gonna be numbers?
Yep. Yep. Mm-hmm. So, I can do a couple examples probably for you. I'll make them up here. Well, there's also chain rules that would go along with these, right? If I had a to the u, you'd get a to the u times the ln of a times du. Just like we have chain rules for all the different derivatives. Alright? So, well, we'll start simple. Y equals 4 to the x power. What's our derivative? Yep. 4 to the x times the natural log of 4. And you don't need to type in natural log of 4 to see what decimal that is and put that decimal in front of 4 to the x. We'll just leave it like that. That's it. Okay? Let me do a chain rule 1. Y equals 3 to the 2x.
Three
3 to the 2x
times log natural of 3
times natural log of 3
Log natural.
is the same thing,
times
times 2.
2. Because you're using the chain rule, you still need to do the derivative of that exponent.
So then would you rewrite that?
Honestly, I don't know the best way to write that. None of them really combine into like terms. I mean, you could write 2 times 3 to the 2x times the natural log of 3. I mean, I'm going to say on that one you'll probably leave it. Any questions on that? Okay, yeah, they'll get a little bit more complicated, or you might have these within a product rule or something like that, but I'm just getting you the general idea here, okay? How about y equals log to the base 7 of x? Let's do the derivative of that.
One over.
So is it x natural log 7?
X times the ln of 7. Yep.
Will we have to prove the derivatives on there?
I think possibly this logarithm one I'll put on there. Not on the one for tomorrow. We're not
Okay.
proving
Okay.
anything tomorrow.
Okay.
We're just doing derivatives.
So memorize those.
Yeah. Log to the base 3 of 6x squared minus 2x. So 1 over
You do 6x squared minus 2x.
6x squared minus 2x
Natural logarithm 3.
times the natural log of 3 times
Oh, and then 12x minus 2.
12x minus 2.
And that goes up front.
I'd end up putting that on top then to make it look a little bit nicer. 12x minus 2 over 6x squared minus 2x times the ln of 3.
Are we ever gonna have to find the natural log of that, like plug it into our calculator?
Well, yeah, because you could definitely have to plug this in your calculator because all the different applications that we've done with derivatives, if I said, okay, what's the slope of the tangent line at x equals 4? Well, now you plug in a 4 here, plug in a 4 here, plug in a 4 here, do all that on your calculator, whatever your answer on your calculator screen is, that is the slope of the tangent line at x equals 4. So that's where you would have to do it, as far as using the derivative to actually apply it to
But
finding the equation of a tangent line. We don't involve logs usually with our velocities at all, but I mean, you could do it for velocity too if that was in your position function, so. But, yeah,
But
so,
for this, you're not gonna.
no.
Okay.
Yeah, that's pretty much it as far as exponents and logs go. Just kinda gotta memorize those derivatives. Make sure you can use those derivatives within your quotients, within your chains, within your product rules. That's kind of all on that test tomorrow.